right, section 7.3 talks about hypothesis testing for the mean when sigma is unknown. Okay, remember, so again, guys, sigma stands for the population standard deviation, right? Okay, so it says in the previous section we performed hypothesis testing for a population mean when the population standard deviation was known. In many situations, the population standard deviation is not known, and so therefore the sample standard deviation must be used instead. This is similar to what was done in section 6.2 using a t-distribution and n-1 degrees of freedom. Okay, so what we're going to do here, it says calculating values for a t-distribution. So the first thing is we're going to specify the level of significance alpha. We're going to determine whether the test is left, right, or two-tailed. And then we're going to find the critical values using table 5. It's the table that I'll kind of show you what I'm talking about in Appendix B in the row of n-1 degrees of freedom. Okay, so it says when a hypothesis test is left-tail, use the one-tail alpha column with a negative sign. If it's right-tailed, use the one-tail alpha column with a positive sign. Let's see, come on, pen. There we go. And if it's two-tailed, use the two-tails alpha column with a negative and a positive sign. Okay, so it says find the critical value T0 for a left-tail test given alpha is 0.5 and n is 21. Okay, so we're using a left-tail test. So a left-tail test is going to be something similar to this, guys. Okay, so my alpha here, in this case, is 0.05. Just a reminder, what does that tell me? That's telling me that the area underneath my curve is 0.05. Okay, so the area underneath my curve is 0.05 and n is 21. If you remember, we did this in chapter 6. We had something called the concept of degrees freedom. And degrees freedom was always going to be my n minus 1. Okay, so in this case, it's going to be 21 minus 1. It's going to be 20. Okay, so how am I going to do this? I'm going to show you how I'm going to do it using my chart, and then I'll show you how to do it using the calculator. So we're going to go to the one-tail alpha column with a negative sign. So I'm going to pull up this. Here we go. We said our alpha was 0.05, so it's right there. And our degrees freedom is 20. So the number that I'm coming up with is 1.725. So I'm going to come back here and I'm going to write down T0 is 1.725, but I want you to notice what it says. We need to write it with a negative sign. Okay, so there I am writing it with a negative sign. All right, now suppose you want to do this on your calculator. So guys, I think a lot of you have either the app, and I know some of you actually have like a TI-84, and some of you have, oh my God, what's the other one called? I have it here on my desk. Oh, let me open it up because I'm forgetting. I can't. The Inspire. There you go. Okay. So when you have those calculators, right here, you're going to go to second vars, and right here under inverse norm, you're going to see one that says inverse t. So I have an older calculator. I have the 83 plus. So mine doesn't actually have that. So what I had to do, I hope it's still here. Let me see. Yes, it is. I had to type in a little program just so that I can do that same thing, but you're going to do it just like we were doing before. So let me clear this out here. Oh, come on, my pen is freezing up again. So let me clear. Okay, so what y'all would do, you would go second vars, and you would scroll down, and right underneath inverse norm, you're going to see inverse t, okay? So I'm going to go to my program because that's what I had to do, and I'm going to hit enter. And the first thing, if you're doing this on your calculator or in your calculator app, and I'll show you how to do it on the app as well, but the first thing it's going to ask you, what's the area to the left? So notice here, we wrote the area to the left was 0.05. So I'm going to type in 0.05, okay, and I'm going to hit enter. And the second thing it's asking me for is, what are my degrees freedom? So we said our degrees freedom was 20, right? So I'm going to type in 20, and then I'm going to hit enter, and it's going to take a second, And I'm coming up with, if I go to 3 decimal places, negative 1.725, right? It's 7247, so if I round it to 3 decimal places, negative 1.725, okay? All right, so now we're going to do the same thing that we did before. It says, find a critical value t0 for a right tail test given alpha is 0.10 and n is 9. So I want you to notice something here. In a right tail test, look where the alpha falls. The alpha is talking about the area to the right. So in this case, my alpha is 0.10. Okay, and if my n is going to be 9, then my degrees freedom is going to be 9 minus 1, which is 8. Now, when I'm using a table or whether I'm using my calculator, these things always compute the area to the left, okay? So if we know that the area to the right is 0.10, then that would tell me that the area to the left has to be 0.90 because the area under the entire curve is going to be 1, okay? So when I come back to my calculator, and I'm going to do this again, I'm going to do my inverse t, okay? I'm going to hit enter. Notice what it's asking me for. It's asking me for the area to the left. Guys, if you're doing this on your calculator or your calculator app, the first number, even though it may not say it, it's always assumed to be the area to the left. So I'm going to type in 0.90, okay? And my degrees freedom in this case is 8. And I'm going to hit enter, and I'm going to wait a second, and it's going to tell me that my answer is 1.397, okay? So I'm going to write 1.397, and this is my critical value T0, right? And you say, well, you know what? Suppose I wanted to use my calculator, my table. Okay, if I wanted to use my table, what do we do for a right tail test? We're going to use the one tail alpha column with a positive sign. So I'm going to come back. Let me grab my chart again. Here is my alpha is 0.10. My degrees freedom was 8. 1.397 with a positive sign. And that's exactly what we had there, okay? All right. So number 3 says, use the critical values negative T0 and T0 for a two-tailed test given alpha is 0.10 and n is 26. Okay, so since we're doing a, come on, pen. Since we're doing a two-tailed test, I want you to look at the picture here. Look what happens when we have a two-tailed test. We have half of alpha to the left and half of alpha to the right. Okay, so what that's telling me is that there's going to be some space here and be some space here. Okay, and these are going to be our critical values. One of them is going to be negative and one's going to be positive. So it has to be half of alpha. So think about it this way. Think about this as like a dime. It's 0.10, right? So then the area here is going to be 0.05, and the area here is going to be 0.05. Okay. And so now the other thing we know is we know that if our n in this case is 26, then my degrees freedom, is going to be 26 minus 1, which will be 25, okay? So again, I'm going to go ahead and use my calculator to do this. Let me clear this out. I'm going to go program in this case. I'm going to do number 1. And again, guys, if you're using a newer calculator, you don't have to do that. You're going to go second vars. So let me just show you one more time just to make sure that we're good. Let me quit this in here. Okay, clear it. So if you're doing this on a newer calculator, you're going to go second vars. Or if you're doing it on the app, you go second vars, and right underneath inverse norm, right here, you're going to see one that says inverse t. Okay, I just have an older calculator, and it didn't have it on this thing, so I had to kind of do it myself. I didn't figure it out myself, guys. I had to Google it, but you get my point. Okay, so it still worked. I still had to do it. Okay, remember, when I'm doing this thing here, y'all, it's always going to be my area to the left, right? So let's take a look. What's the area to the left? The area to the left right here is 0.05. So I'm going to type in 0.05. I'm going to hit enter. What's my degrees freedom? We said it was 25. I'm going to hit enter. And I'm going to wait a second. Okay. So remember, we said we're going to get two answers. One of them is going to be negative, one's going to be positive. So negative 1.708, excuse me. So this one here is negative 1.708, and this one here is a positive 1.708, right? And if you wanted to use the table, if that was what your thing was, it says use the two tails alpha column with a negative and a positive sign. So remember, the answer I'm looking for is negative 1.08. Oops. Let's see, two tails, 1.078. Where would it be? Trying to see if I can find it. Here we go. 1.708, right? Two tails, alpha was 0.10, degrees freedom was 25, and there it is right there, okay? So I think the calculator is probably a lot easier than having to mess with the table every single time. But again, it's really entirely up to you which way you like better. I just think the calculator works much, much quicker. Okay, so now, the process and how I'm going to do this, y'all, is going to be the same way we did in 7.2. It says the t-test for a mean mu. It says the t-test for a mean mu is a statistical test for a population mean. The test statistic and the sample mean x bar, and the standardized test statistic is given to us by this formula right here. When the sample is random, the population is normally distributed, or our sample is bigger than or equal to 30, and our degrees freedom is n minus 1. Okay, so using the t-test, I'm sorry, for the mean mu. So we're going to verify in words that the population standard deviation, because that's what this stands for, is not known, right? The sample is random and either population is normally distributed or n is bigger than or equal to 30. We're going to state the claim mathematically and verbally, identify the null and alternate hypothesis. So that means we're going to find the HO and the HA. We're going to specify our level of significance. We're going to find our alpha. We're going to find our degrees freedom. We're going to find the critical values. Again, we can use the table or we can use our inverse T. We're going to determine our rejection region. We'll find the standardized test statistic and sketch the sampling distribution. We will make a decision to reject or fail to reject the null hypothesis, and then we'll interpret the decision in the context of the original claim. Okay, so let's see if we can figure out how to do this problem here. It says a used car dealer says that the mean price of a 2-year-old sedan is at least $20,500. Okay, so the first thing I'm going to do, we're going to say, let me see, that mu is at least 20,500. So let's think about what that means. At least 20,500 means it's that number or more. So it's telling me that my mu is greater than or equal to 20,500. So again, I want you to think about that the term at least. A lot of times people think that means smaller than. But think about it this way. If we said at least, like if I want to say I want to make at least $100,000 a year, that would mean that I want to make $100,000, right? Or more, wouldn't it? So that's what the term at least really means, okay? So it's going to be greater than or equal to. So first off, this here is my claim, right? Looks like I wrote two N's because I did. There we go. So we want to say, what's the opposite of saying mu is greater than or equal to 20,500? Then we would say mu is less than 20,500. Okay, the next thing is we need to identify the null and the alternate. So remember, the null, the HO, is always the one that has the equal to part. So then this is my HA. Okay, so let's just come back here. All right, let's see. I'm going to keep reading. It says, we find in a sample of 14 vehicles. So this is telling me that N is 14. So remember, my degrees freedom, sorry, I meant to close this little part up. My degrees freedom is going to be one less, which would be 13. So it says we have a mean price, so my X bar is 19,850, and it says my standard deviation is 1,084. So one thing I want to mention here, because it didn't specify that it was a population standard deviation, we have to assume it's a sample standard deviation. So again, before I go on, I want to mention a couple of things. Remember what we said earlier? This here stands for the population. I'll just abbreviate it, standard deviation. So if it doesn't specify that, then we're assuming that we have the sample standard deviation, okay? Let's see, it says, is there enough evidence to reject the dealer's claim at alpha as 0.05? Assume that the population is normally distributed. Okay, so first thing is, we know that alpha is 0.05. Second thing, is this a left tail, right tail, or two tail test? The way we determine whether it's left tail, right tail, or two tail, we always look at the ha. Okay, and the ha in this case is pointing to the left. So this is going to be a left tail test. My alpha here is 0.05. Okay. So if I know that my alpha is 0.05, I want to find that critical value T0. Okay. So the way I'm going to do this, I'm going to take my calculator. Okay, I'm going to turn it on. And let me clear this. Let me hit my program. Good, it's still there. Okay, what's the area to the left? 0.05. What's my degrees freedom? If you look over here to the right side, it's 13. Okay. And we're going to find our critical value T0, and it's going to be negative 1.771. So negative 1.771. All right, so now that we found that, okay, let's see. So we found our level of significance because we identified alpha. We did our degrees freedom. We found our critical value. We just found it right here. Okay. Now we're going to determine our rejection region. So again, just a quick reminder, y'all. I'm going to zoom in a little bit. And remember, this here is my fail to reject. And this here is my rejection region. Okay. All right. Now we're on to number 7. So it's moving pretty quick, right? So far we're doing okay. It says we're going to find the standardized test statistic, and we're going to sketch the sampling distribution. So this is the formula that I'm going to use, okay? It's similar to the formula we've been using before. Let me zoom back out a little bit so we can see everything. Okay, there we go. So T is equal to X bar minus mu. I'm going to put this in parentheses so I can do it on my calculator, divided by S over the square root of N. Okay. So X bar, we wrote it down somewhere here. We go 19,850. 19,850 minus mu, which is 20,500, all divided by S, which was 1084, over the square root of N, which was 14. Okay. So let me get my calculator again. Let me clear this. All right, I'm going to type in exactly what I see. 19,850. Oops. 19,850 minus 20,500 divided by 1084 divided by the square root of 14. I've got to close them twice. I'm going to hit enter. Okay, and I'm going to go again to 3 decimal places. I'm coming up with a negative 2.244. So I'm getting a negative 2.244. Okay, so now, let's see, what does that mean? That is my standardized test statistic. So what I need to do is I need to figure out where would this number fall in comparison to my negative 1.77777771, whatever it was. Okay, so just to give you again an idea, remember right here in the middle, this was 0, this was at negative 1.771. We came up with a negative 2.24. That's going to be even further to the left. Negative 2.244 falls even further to the left, and it falls in the rejection region, right? So now, what do we say we're going to do? Because it fell in the rejection region, we're going to reject that null hypothesis, okay? All right. Now that we rejected our null hypothesis, I'm going to come back. Let me see if I can pull this up here. Here we go. Same thing we've been using when I did the other video. I said the other day because I made it the other day. All right. So which one was my claim? My claim was the null, and we decided to reject it. So if my claim is the null hypothesis, let me see. If my claim is a null hypothesis and we rejected it, we're going to say there is enough evidence to reject the claim. Let's see, here we go. There is enough evidence to reject the claim. That doesn't look like a C, does it? Boom. And we're done. Okay. So look, there's another one, number 5. So let me zoom in on this one and we'll do it the same way. Okay. So let's start reading it. It says, an industrial company claims that the mean pH level of water in a nearby river is 6.8. Okay, so I'm going to stop right there. Oops. They're telling me that mu is 6.8. This here, oops, is my claim. Okay. So what is the opposite of saying something is equal to 6.8? Saying it's not equal to 6.8. Okay. So now the next thing is this here is my null, and this here is my alternate. Okay. All right. Now, it says we select 39 water samples and measure the pH of each. So that's telling me so far that my N is 39, which tells me that my degrees freedom is going to be 1 less, which will be 38. And it says the sample mean and standard deviation are 6.7 and 0.35 respectively. So my sample mean is 6.7, and my sample standard deviation is a 0.35. Okay. And it says, is there enough evidence to reject the company's claim that alpha is 0.05? So my alpha here is 0.05. Okay. So now that we have those pieces of information, the next thing we got to figure out, is this a left tail, a right tail, or a two-tail test? The way we figure that out, we always look at the ha. Since this is telling me it's not equal to, then this is going to be a two-tail test. Okay, so we're going to have two pieces here. These are going to be my rejection regions, and the one in the middle, y'all, is going to be my fail to reject. Okay, so now we got to figure out what is going to be the alpha here and the alpha here. I got to take this number and divide it by 2. So it's going to be 0.025. That'll be the area in that piece there and in that piece there. Okay. So, excuse me. So now if I want to find those two critical values, remember one of them is going to be negative and one's going to be positive. The way I'm going to do this, I'm going to take my calculator, turn it on, okay, and I'm going to hit program, and well, you'll hit second vars, and you'll go down to inverse t, right? I just don't have that. So I'm going to go to my program, my inverse t. I'm going to hit area. or enter, it's asking me for the area to the left. Look at the area to the left. The area to the left is at 0.025, right? So 0.025. Hit enter. The next thing it's going to ask you for is, what is our degrees freedom? We wrote that down over here to the right, and it was 38. That was my degrees freedom. I'm going to hit enter, and I'm going to, hit enter. There we go. And it's going to give me my answer. So I'm coming up with a negative 2.024. So this right here is a negative 2.024. And this one here is a positive 2.024. Okay. All right. The next thing we're going to do, we're going to find our test statistic. The way we're going to do that is we're going to go x bar minus mu divided by s over the square root of n. Okay. So my x bar in this case is 6.7 minus 6.8. S is 0.35 divided by the square root of n, which was 39. Okay. So let me get my calculator, and I'm going to enter it exactly as I see it. 6.7 minus 6.8, close it off, divided by 0.35 divided by the second square root of 39. Okay, and hit enter, and I am coming up with a negative 1.784. So negative 1.784. Here's the number that I'm coming up with, okay? So now, let's see where that number is going to fall on my picture. I'm trying to make it where I can see a little bit of everything. All right, so negative 1.74 is actually going to be somewhere to the left. It's going to be between those two numbers. It'll be negative, but it'll be somewhere in here. So where did we fall? We fell in our fail to reject region. Okay? So now we're going to say right here, we're going to say we fail to reject, right? The null hypothesis. Okay? We failed to reject the null hypothesis. I don't need to zoom out that far. Okay, so now, next thing I'm going to come back over here, and I'm going to say, okay, which was my claim? Well, my claim actually happened to be the null hypothesis, and we failed to reject it. So let me pull this up again. Let me pull this up again, and let's see. Our claim. So I got an eraser here. Here we go. Okay, there we go. That's a little bit better. I can see that better now. Okay, our claim was the null, and we failed to reject it. So now what we're going to say is we're just going to say there is not enough evidence to reject the claim. There is not enough evidence to reject the claim. There is not enough evidence. To reject the claim. Okay. And that's it. Okay. So that right there, guys, was 7.3. I hope they're kind of getting a little bit easier as I'm going through this. But, you know, you guys let me know.